Today I'm going to go over operators, and I'm going to go over the different types of operators, concentrating on unary operators and binary operators. We'll go over a little bit about ternary operators, and then I'm also going to go over math library functions that we use with the math library, and we're going to go over implicit and explicit casting. But for part one, I'm going to see if I can get up to operator terminologies, and we can just have that settled down. And for part two, we will start with unary operators in the library functions for math, the math library, and the explicit and implicit casting. So that's the plan for today. So let's go back to our C++ IDE, and I've already created a project. At this point, if you don't know how to create a CPP file, I suggest you go back to week 1 and you start going over it again so that you remember how to create your first CPP file. Now, with operators, and when I talk about operators, I'm talking about arithmetic operators, the addition, subtraction, multiplication. Then we're also going to talk about something called unary operators, which just act upon one operand, and I'm going to teach you what each term is. So the first thing we need to straighten out is terminology. So what's an operator? An operator would be the symbol that acts upon a variable, or what we call as an operand, and which gives you a result. And I'm going to show you a simple example, and you've probably been doing this, or if you read ahead, you probably know how to do this already. If I say, let's declare it, okay, and then if I say sum equals I plus y, and let's analyze this statement so that we are familiar with the terminology. This addition is called an operator, okay? And the operator, if it's a binary operator, then it's going to operate on two operands. This would be the left operand, and this would be the right operand. Let's go over that again. This is an operator. The operator acts upon a left operand and a right operand if the operator type is binary. We're going to cover first the binary operator types. That would be addition, subtraction, multiplication, division, and modulus. These operators are the easiest to comprehend, and then we'll go down to the unary operators and other operators that you've probably seen online or on other websites, and you may even have seen it if you've read across the book. Okay, now this operator is it's an addition operator, and it's acting upon the left operand and the y operand. If we substitute this I value for what we assigned, and we substitute the I value and then the y value for what we assigned, you really have 5 plus 10, and the result of that is going to be stored in sum. Sum, like I and y, are variables, and we've gone over this in previous lessons where once you declare a variable, you're declaring a memory space in memory. Now, terminology, we call this an L value and an R value. And this is known as an assignment statement, because you're assigning the result of I plus y into sum. This is also called an assignment statement because you're just assigning 5 into the variable I. This is an assignment statement, and this is an assignment statement. do you know what the difference is between a declaration statement and an assignment statement? Declaration statement is just a declaration of a variable. So if I say number 1, that's a declaration statement. Within my declaration statement, I can turn that into also an assignment statement, so I can combine them both, which is what I've done here. I've declared I, but I've also assigned it the value of 5. So let me give you a couple of examples. I can say that, but at this point, if I compile and run, nothing's going to happen as far as output to the user, because I'm not using the cout operator to the cout object with the insertion operator for putting output to the console window. Okay, again, you remember our old friend cout object, and you need an insertion operator so you can insert output to the output console window. And I can just say sum. Okay, so when I execute, compile, and run, you have the value of 15, because I took I plus y, which I assigned it the values 5 and 10. So 5 plus 10 would give you 15. Okay, let me pause for a minute so that you can look at the code. Okay, so we're back. Now, if I do a combination of operands, this is known as an expression. And what I mean by that is, I can use a variable, or I can also use a literal, a numeric literal. So I can do, let me do this. Sum is equal to I plus y times 5 divided by 2 plus 8 times 3. What I've built here is something called an expression. This expression is a mix of literals and variables with an assignment statement. And the result of that equation, of that expression, is going to be stored into sum. So let's see what happens when I compile and run this. If I say compile and run, it's going to give me 46. Now, the other thing you have to realize is, when you're doing an expression, you have to look up what the order of precedence is, as well as associativity. Now, we go into the definition of what is associativity. Associativity tells you which way you're going to evaluate depending on the precedence of the operators. So for example, if you look up on Google, I'm going back to the reference, you can look up something called order of operators. Okay, you go into the first link, and it's going to tell you what the precedents are in terms of what operators go first. In this particular case, we have the multiplication, division, and modulus operator have the same precedence, right? They both have the 5 as precedence. The associativity means that you do left to right. So, if you have a mix of a multiplication and division, because they're of the same precedence, then what you have to do is just go from left to right. Let me give you an example. Okay, so if I do sum equals 5 divided by 2 times 3 divided by 6. Okay, because the division and multiplication are of the same precedence per this chart, that means that the associativity is left to right. That means that I have to evaluate from left to right. So I would do 5 divided by 2, which is integer division. Okay, 5 divided by 2 will give me 2, times 3 would give me 6, and then 6 divided by 6 is 1. So let's see if I'm on the money. It's 1. Okay, as you see that. So I hope you understand the logic that goes in here. Oops, sorry, the end line. Okay, so you have to pay attention to not only the precedence, but also the associativity. Now, as you know in math, anything that's in parentheses will be evaluated first, and you can save yourself a lot of headaches if you know that if you want this to be evaluated first, and then you want this, and not have to rely on the compiler. So what happens now is anything in parentheses will be evaluated first. So this will be evaluated, and then this will be evaluated, and then you do the multiplication. Same goes for if you mix addition and multiplication as we did here. Okay, we mix addition and multiplication. What happens is this one has to start at y times 5, right? Because it goes from left to right, the associativity. You can't start I plus y because multiplication comes before, precedence is before the addition and subtraction. Again, I repeat, if you want to avoid having the compiler evaluate the precedence for you, then just wrap everything that you want evaluated in the order that you want in parentheses. It's pretty easy. Now, so we've gone over addition, subtraction. So what does a modulus operator do? The modulus operator, what happens is you have a division problem. Let's talk about division. So if I do 5 divided by 2, because we're using integers, we're not going to get back a decimal point number, a floating point number. We're going to get back a whole number because 5 and 2 are integers. So what happens is 5 divided by 2, if you do integer division, it's going to return 2, and it's going to drop off the remainder. So let's try that. So see that? I only get 2. I don't get. If I wanted to do floating point division, first I'd have to declare sum as a double, and then add the floating point notation to my variable. So if I do compile and run, you're going to get 2.5, because what I've done is I've changed the literals. Remember, each numeric literal has a type in the compiler, inside the compiler. The way you write it will automatically cast it. I can't say cast, but it'll automatically convert it to the type that you're writing at. The minute I write 5.0, the compiler knows that that's a floating point number. 2.0 is a floating point number. So that means that I can store that in a double variable. And once I'm in a double variable, then the result is gonna have the floating point result. Again, if I go back and make this an integer, I do that, and it'll do integer division, and it's gonna cut off the remainder. So if I do compile and run, so it's 2. Okay. Now, there's another operator called modulus, and this is actually bad style that I'm writing it. Modulus will not give you the result of a division. It'll give you the remainder. So if I was doing sum equals 5 modulus 2, what you're really doing is you are saying, and let me draw this in paint. Actually, it'd be better for me to just explain it to you. How many times can 2 go into 5? 2 goes into 5 2 times, right? Because 2 times 2 is 4. But what's your remainder? It's 1. Modulus will give you the remainder. So if I execute, compile, and run, it's going to give me 1. Because, again, the modulus operator gives you the remainder of the division of the two operands. Okay. Now here, as you've seen before, you can mix expressions for all these operators. Not only that, I can have something like this, 5 times 3, and let's do something like that. And then this can be 2 plus 5. Okay, and you got to remember, the one thing with modulus is the operands have to be integers. The operands have to be integers. So if you try to do a floating point L value and an integer R value with the modulus operator, it's going to give you a compiler error. You're not allowed to do that. Modulus only accepts this as an integer and this as an integer. Okay? And what I built here is an expression. And within this expression, I'm also creating an assignment statement to the value of sum. Okay? Now, there's also something called a side effect of an expression. There are some operators, particularly the unary operators, that will have a side effect after the expression has been executed. Meaning that if I use a unary operator within this expression, the value won't be changed until after this is executed. And I'll show you how that works in unary operators, more precisely the postfix incrementer and the prefix incrementer. Okay? But again, that's the lingo, something called a side effect of an expression. So when you hear the side effect of an expression, it means that there has been an evaluation and a change of value in a variable in your expression after execution of your expression. Okay? Okay. So we've gone over associativity and the order of precedence. And again, if you look at this page, it's going to tell you the precedence of the operators. We have the arithmetic operators 5 and 6, which are the ones that we've gone over. And we're going to go over the logical and the OR later in the semester. And then you have the ternary conditional, which is a ternary operator. These logical ands and ORs are binary, as these are. These are also binary because you have less than, greater than. And these here are unary. And we'll go over a couple of these. Okay? So what else you need to know? We've gone over the L value and R value. So this, in this particular expression, this would be the L value. Okay? And this would be the R value. And this would be the result of the assignment. Okay? So what I want you to do is, you got to follow with me and type these examples in so that you understand how it works. So let's take a look at a couple of examples that we can do on the fly. With cout, I can also write out expressions and they can give me a result. So if I do 4 times 6, okay, and I compile that, that's going to give me 24. Because what C++ does is it takes the actual operator and does the execution of the expression. Okay, and you can try it with a mix of everything. You can put an expression with variables and literals. And again, the addition, subtraction, multiplication, division, and modulus operators are binary operators. This is the left operand, and this is the right operand. And right here, there's no L value. Okay. Now these terminology of L value, it's on the lecture. But again, the most important thing is not too much of the terminology, but just knowing that with this expression, you're assigning, and you recognize that you're assigning that the result of this expression is being stored in the variable called sum. Okay, so let's do another example here real quick. If I do int num, and I'll do my style, right? Num1 equals 5. I num2 is equal to 7, and then we need a variable for the answer. So answer num1 times num2 and if we execute this, you're going to get the value of 35. Okay, again, I correct myself before. This is called the L value, but this is also an assignment statement with a left operand and a right operand and an operator. Okay, and from the lecture slides, this is the R value. So the R value is this whole expression. Okay, just so I don't mix you up. And you look at the lecture slides and then you compare it to my video. I don't want you to get confused. So again, I repeat, this here is the R value and this is the L value. Okay, this is the left operand and this is the right operand and this is the operator. Okay, and as you've seen in an expression, you can have multiple and a mix of operators, and you can have a mix of operands. Okay, now let's do a floating point example. If I do double num1 is equal to 5.2, num2 is equal to 2.1, and answer. So now I'll have an assignment to answer, and I can make that a double. This would be a double, and then d num1 times d num2, and then I see out answer, which is the answer. And compile and run this. 10.92, because again, I declared two double variables and they're treated as floating point variables, and I'm assigning them to a double result or a double variable, the answer, which is going to store my result, and then once I print that out, then it's going to show up as a decimal output. Now again, you can play with this, and again, you can always use the set precision and fixed point manipulators so that you get familiar on how to manipulate the output. Okay, as I've spoken before earlier, you have to pay attention at the order of precedence and the associativity. The way it goes is if you're looking at an equation, so if I do something like that, plus 6, right? Plus 7, whatever. You go to your little chart here, and you say, okay, this has no parentheses, so I have to look at the order of precedence. Who goes first? Well, if I look at it, we see that multiplication comes before addition and subtraction. Okay? So the order of precedence means that this multiplication and this division will have first dibs at their operands. But because now we're looking at the order of precedence for multiplication and division are the same, right? This is 5. The associativity is left to right. So what that means is that we have to execute this expression from left to right up to here, and then add the 7, because addition's precedence is lower than the multiplication and division. Again, you have to understand the chart of the order of precedence and associativity, and it's the same as your math rules. If you look at your algebra rules in terms of what goes left, what goes right, with the parentheses and all that, and you see it here. The parentheses, okay, always go first. Okay, so I just want to give you an example where this can kind of bite you in the butt. I'm going to comment this. I will say 100 plus 50 plus 75 divided by 3. And I have to put this in parentheses or else it's going to give me a syntax error. Okay, just looking at the equation itself, you think that you can do addition. If you didn't understand the order of precedence and associativity, any person would just say, well, you would do this plus this divided by 3. Okay? If you didn't understand the order of precedence and you just said, oh, let me go from left to right, so you would do 100 plus 50 plus 75. That would give you 225 divided by 3, which is 75, right? You would think that the result would be 75. But again, because of the order of precedence and associativity, that's not the case. As you see here, the answer is 175. Why? Because division goes first. Division has 2 operands, 75 and 3. What we do is we say 75 divided by 3, okay, is 25. And then you do the remaining, right? Because division goes first, and then the order of precedence for addition is 6. So it goes after division. 25 plus 100 plus 50 will give you 175, and there you have it. So you have to be careful and understand this order of precedence chart and the associativity that's built within C++. Okay? And C++ is a language of precedence and associativity and all that, what goes first, what goes last. But again, in order for you to avoid all this, easy thing would be to do that and that. Now that I've placed my parentheses over my addition expression here, part of my overall expression, now you're going to expect the answer to be 75, which it is, because it's going to evaluate whatever is in parentheses first and then do the division. So there you go, 75. Again, this was what I was talking about earlier, that if you want to cut your losses, just put anything you think that you want evaluated first in parentheses and don't let the compiler decide for you, because it can get you in a lot of trouble. Okay? Okay. This concludes our lesson for operators and operands. And the next lesson will be about unary operators. And I will be closing this lesson now. And I hope that you did understand what I was trying to teach you here. If you have any questions, please contact me.